So when we talked about expected value before, we really focused on expected value in terms of games of chance. So different ways that you can gamble or games that you can play or raffles you can do. Okay. But there are a lot of uses of expected value beyond just dealing with gambling questions. Okay. And that's what I want to look at today. So let's take a look at this first problem here. This first problem, we already have the expected value calculated for us. So according to the U.S. Bureau of Census, around 4.2% of seniors over the age of 65 are in a nursing home at any given time. So this right here, that is an expected value. Okay, it's based off of data that we have in the past, but we have an expected value here, a percentage. Okay. What you can use expected value for is then you can say, well, if you have 500 seniors in a particular group, how many of them can you expect to see fulfill this expected value? So just like before we said, if your game is losing 25 cents and you play it 100 times, right, then you would expect to lose $25. Well, the same thing here. If our expected value is 4.2% or 0.042, then we apply that to 500 different people, right? Then our probability works out to 21 people. So our expected value is that 21 people, 21 seniors should end up in a nursing home. Okay, so that is the idea of any kind of like insurance that you're dealing with, or any kind of a company that runs something that deals with like having people. Like you can just sort of imagine all the implications of this kind of thing. Okay, being able to figure out this expected value then allows you to make predictions. Okay, it lets a nursing home look around their area and say, in the next 10 years, we're going to have 500 seniors in this area, right? And we're going to expect that 4.2% of them are going to need a nursing home, and that's probably us. So we're probably going to have about 21 more people. Okay, so there's a lot of applications when it comes to expected value. I want to talk about insurance. Okay, so this one, you got a 40-year-old man in the U.S. has a small percent risk of dying during the next year. A little morbid, but we can deal with it. So insurance companies, right, charge $275, or a particular insurance company charges a $275 for a life insurance policy that pays a $100,000 death benefit. So basically, you pay for this amount of money, right? And then if you happen to die, then they pay out $100,000. Okay? We want to know what's the expended value for the person buying the insurance. So the tricky thing about insurance, like these kind of problems, is that you really have to pay attention to from which perspective you're looking at. Because in this case, this $100,000, if you look at it from the perspective of the person buying the policy, it's a gain. But if you look at it from the perspective of the insurance company, that's the loss. Okay, so you just got to kind of pay attention and then interpret your answer. So in this case, we're going from the perspective of the person buying the insurance. Okay, so let's take a look at this. So from the perspective of the person buying the insurance, okay, if you die, so there is a point, slide your decimal over twice, right? So 0.00242 chance of dying during the year. Okay, if you die, they're going to pay out this death benefit minus the policy that you've already paid for, right? So if you die, so this is the probability of dying, right? These are the realities you have to face as you become an adult, right? And then it's $100,000 minus the $275 premium, this lovely number right here. So you would walk away with a gain of about $99,000, right? Okay, so then we're going to add to that the probability of you living, right? So remember, probability always adds to 1. So 1 minus 0.00242, that's the probability that you live, okay? So there is a 0.99758 probability that you live. And if you live, you're out the $275 that you paid for your policy. So that's the probability of living. Cool. All right. So let's take a look at this. Let's actually calculate it out. So 0.00242 times 99725, and then plus 0.99758 times negative 275. Works out to negative 33. Okay, so that's our expected value. And again, remember, we did this from the perspective of the person buying the insurance, right? So what this is telling you is that for every, and this is really just looking at, per year, right? I'm assuming that this insurance policy is that they're charging you $275 for the year. Okay, so assuming that, what this is basically telling you is that on average, paying for this insurance, you're going to lose $33 a year. Okay, so on average, you lose $33 per year. Right? And it's a little bit more complicated than that because your insurance policy rates change as you age and get into different brackets and different risk factors and stuff. Okay, but that's the general idea. Okay, so when you look at this, when you talk about insurance, the understanding is that when you pay for insurance, you're losing money in the long run. Okay, so then why do people bother with insurance? Like, if you know that you're going to end up losing money in the long run, then why bother, right? Well, because if you do die, that benefit for some people outweighs the fact that you're losing money, right? They look at it and say, like, yeah, maybe I'm going to be losing $33 a year, but I would rather pay that $33 a year for the insurance that if I die, my family's going to be taken care of. They're going to get some money and they're going to be able to survive my death. Okay, so that's the understanding of insurance, is that you're paying understanding that hopefully you're not going to die. Like the hope is that you buy insurance and then you don't die, right? So you're hoping that you won't die, but you're understanding that you're paying for the assurance that if something does happen, then you're covered. Okay, so that's kind of the idea of what's going on with insurance. Okay, so this is like a whole field of mathematics that people do where they just look at, like, how much do we charge? How much should we charge for these different things? If we're going to have an insurance policy, how much should we charge for a person? Like, is 275 a good amount? Should we raise it? Should we lower it? How do you know? Okay, so it's a really interesting field of mathematics. All right, let's look at this next one. So according to Motorola, around 34% of Americans break their phone screens. So they decide that they're going to sell an insurance policy with their phone for just strictly replacing cracked screens. Okay, and Motorola knows that it costs them about $30 to replace the phone screen, including all the cost of the parts and the people doing it that they have to pay and all that stuff. So the questions here, so first off, I want you to just think to yourself, what do you think would be a reasonable cost for this insurance policy? So for a year, you come in, you break your phone, they replace it for you for free. What would be a reasonable price for you to pay? Okay, so that's kind of an opinion question, all right? But now we're going to sort of build off of this. So let's take a look at the calculating it. So we want to look at how much they should sell the policy for in order to break even. Remember our good friend breaking even? That means they're not going to lose money and they're not going to make money. They're just strictly going to break even. Okay, so let's take a look at this. So there's a 34% chance that somebody on this policy would break their screen, right? So 0.34. And if they do break their screen, Motorola has to pay out $30. Okay, so notice that this time, before, when I did this problem, I did it from the perspective of the person buying the insurance. Now I've shifted and now I'm doing it from the perspective of the company selling the insurance. Okay, so you just have to pay attention to which way you're looking at it. Okay, so that's our probability of losing out. Now, that leaves us with, since probability adds up to 1 or 100%, right? That leaves us with a 0.66% chance, right, that they don't break their phone screen. So what we're asking, well, how much money should we have them pay so that in the end, it's going to work out to breaking even? Okay, so how much money would they have to pay? And you know what? I just realized I forgot something, right? Because if they're paying money, I'm not straight up losing $30, right? Because we have to take a look at our net gain. So if I'm making X the cost of the policy, right, then they're not just going to lose $30. right? They're going to lose the $30, but they're going to gain however much they charge. Okay, so if they charge $5, it'd be a net loss of $25, right? Okay, and now we have this lovely little equation that we're going to solve. Okay, so I'm going to do distributive property here. So 0.34 times negative 30 works out to negative 10.2. And then it would be plus 0.34x plus 0.66x equals 0. Bring this over to the other side, add those guys together. That adds to 1, right, by design. So if they strictly want to break even, right, they should just sell their policy for $10.20. So $10.20 would let them break even. Okay, so then you probably don't want to break even if you're a company, right? In the goodness of your hearts, right? You don't want to break even. You want to make some money. So what would we want to sell the policy for if we wanted the expected value to be at least $100? Okay, well, let's take a look. So now we're saying, all right, there's a 34% chance that they break their screen, right? And we lose $30, right? But we'll gain whatever it is that the cost of the policy is no matter what. Okay? Add to that the probability of them not breaking their phone, and then we just gain money. And we want to know what amount do we have to sell it for, so our expected value is $100. All right, distributive properties. So this we already figured out is going to work out to negative 10.2 and then plus 0.34x. So add those guys together, that works out to x, and this is going to work out to 110.2. So they have to sell it for $110.20, right? Notice the connection between those two numbers? Once you figure out your break-even point, if you want to adjust it from there, you just adjust your price. All right, now practically speaking, is this possible? No, because no idiot would be willing to pay $100 for an insurance policy to replace a screen that costs $30, right? So as a company, they have to decide on a happy medium, right? They have to be able to look at this and say, okay, well, we want to charge more than $10.20, so we're at least making something, but we're not going to expect to make a lot of money on any one individual customer. How do they make their money? Well, they make their money by saying, let's sell this policy for $11. Okay, so they sell this policy for $11, which means that they're going to work out to gaining about 80 cents per customer. Okay, and then they say, well, we're not just going to sell this to one customer, though, right? We're going to sell this policy to 100,000 customers. So that 80 cents that they're gaining times those 100,000 customers, that's some pretty decent money for them, right? And for you, it's worth the risk because you look at it and you say, okay, well, for $11, right? If I do break my screen, that's going to save me some money. But if I don't break my screen, then it's only $11, right? So from the perspective of the consumer, it seems reasonable because for the one given consumer, it's not a major loss. But for the company who has many, 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 many consumers, it works out to a large gain for them as a whole. Okay, so that's how insurance companies stay in business and that's how they make money. It's not off of any one particular person, right? There will be times when you have an insurance company, right? And you're going to have somebody who dies and you have to pay out the $100,000 when they've only given you $275. And yeah, you're going to lose money on that deal. But that's not your only customer, right? You have hundreds of thousands of customers. And because of that, that's what allows you to make money over time.